Today we will study about the Cartesian sign conventions. See, these sign conventions are very important. Very important in the sense you are sure to get about a question from this using Cartesian sign. Actually, this complete chapter is based on Cartesian sign conventions. Okay. So sign convention means sign means up to now we have studied only two signs, positive and negative. Okay. As per our quadrant system in mathematics, what all we have studied in mathematics, we have studied about a quadrant. See, we have seen that you have the x-axis and y-axis. That's what we have done. Okay, see. We have done that. Let this be the x-axis, be the y-axis. And we know that from the origin, all the measurements which will be made towards right, they are taken as positive measurements. This is what we have studied in mathematics. Okay. In mathematics, we have done this. That measurements towards right will be taken as positive. Measurements towards left will be taken as negative. All the measurements above this x-axis, so these measurements, they will also be positive, and the measurements below this will be taken as negative. Right? We have studied this. Yes, everyone knows this formula, that how
Yes,
the
sir.
yeah. So the same thing applies to physics also. With just one change, there is just one change in physics. With that one change, this formula is applied in physics also. The same thing, the same sign conventions, they are applied in physics also. Now, what the change is, the just 1 minute, 1 minute, beta. So I told you that these sign conventions will be applied everywhere. Sign conventions applied everywhere. In physics also, we apply the same sign convention with just one liberty given in physics. And that liberty is that it's not necessary that you will be taking this right side to be the positive. You can take the left side to be the positive and right side to be the negative. That is up to you. Right? So with this knowledge that this can be changed. Now, but condition given is that which direction we will take as positive. So which direction we will take as positive, now that depends on the direction of the incident light. The direction of the incident light will be taken as the right direction or will be taken as the positive direction. For example, if I am talking for the plane mirror, suppose this is a plane mirror, and on this plane mirror there is some light ray which is incident. Okay. So a light ray is incident on this mirror like this. So you have this incident light. From here you also get your reflected light. So this is your incident light. You have the reflected light. Now, which direction should we take? The direction of the positive direction. So if I am making the measurements from this point, so from this point, the direction of incident light, so incident light is falling towards the mirror. So from the mirror, I will take this direction to be the positive and this direction to be the negative. Measurement in the opposite direction of the incident light will be taken as negative, whereas measurement in the direction of positive incident light will be taken as positive. Okay. Now let us try to apply the same sign conventions for the case of concave mirror. So first of all, let us write what are the conditions. How do we apply the sign conventions over in the case of mirror? So sign conventions in case of mirror, we take the direction of incident light. The direction of incident light is taken as positive. So the direction of incident light is taken as positive, and all measurements are done from pole. Okay. So all the measurements are done from the pole. Now we consider the pole of the mirror to be the origin. So let us try to apply the same thing with the concave mirror and with the convex mirror also. So these 2 points should be kept in mind. And we also call these as sign conventions. So whenever I will be talking of sign convention, I especially refer to these 2 points. Okay. So see, we will have a concave mirror. Okay. So let us draw the principal axis. Here also I have the principal axis. Now let this first mirror be the concave mirror. And let this be the convex mirror. So, so these are the points. This is your pole. This is also a pole. You have the center of curvature, you have the focus and focus here also. Now, let us draw the incident light first to observe that which direction we will be taking as the positive direction and which direction we will be taking as the negative direction. Okay. So, we take the incident light. On the concave mirror, this is the direction of the incident light. Whenever you take the object, this will be the direction of incident light. The incident light will always fall towards the shiny surface. With the case of convex mirror, the incident light will be falling like this. Okay. Now, why I am saying every time, why I can't say the right side and the left side? Because you can draw the same concave mirror other way. You can draw the concave mirror like this also. You can draw the concave mirror like this, with this side being the polished surface. Okay, so we'll refer to these situations. Now see, as I told you that all the measurements will be made from the pole. So suppose this is your pole now. So for the concave mirror, this is your concave mirror. For concave mirror, what should be the value of radius of curvature? Yes, for the concave mirror, what should be the value of the radius of curvature?
2f.
Okay, should it be positive or negative?
Positive.
Negative.
Negative.
See, from the pole, the incident light should be taken as the direction of the incident light to be taken as, this is the first point, direction of incident light is taken as positive. So from the pole in the direction of incident light, if I'm making any measurement in the direction of incident light, that has to be taken positive. So I will be taking this direction from here. I will take this direction to be the positive direction. If I'm making any measurement away from the pole like this, so this will be the positive measurement. And if I'm making any measurement from pole opposite to this like this, so this will be a negative measurement. Got it? So this side you have the positive measurement, you will have the positive, and this side you will have the negative measurement. So with the help of concave mirror, the radius of curvature should be negative. Anyone having any doubt?
No, sir.
No. What about the focal length? What about the focal length? Should the focal length be positive or negative?
Negative.
Negative.
Negative. We should have the focal length to be negative. What about the object distance?
Negative.
Negative. Since object is also situated in front of the mirror, so object distance U should be taken as negative. What about the image distance? If the image is a real image,
Negative.
image distance, if the image is real,
It's
so I say
negative.
here that image is real, then image distance will be negative. How we see? When a real image is formed, it is formed in front of the mirror. Okay, so a real image was formed inverted. If you remember, we had drawn the real image. The real image was formed inverted and it was formed in front of this mirror. So the distance from pole to this image will be negative. It is on this side, so it should be negative. Now, when the image is virtual, when the image is virtual, so that means if you remember the ray diagram, in that case, the image was formed on this side of the mirror. It was erect and on this side. So this side of the mirror is taken as positive. So here image distance will be positive. Everyone understood?
Yes, sir.
Yes, sir.
Yeah. Anyone having any doubt?
No, sir.
No, sir.
Okay, see. So you can remember in a short like this, for a concave mirror, everything is negative except the image distance when image formed is virtual, or when the image is formed behind the mirror. That is the only case we will be taking image distance as positive. Okay. Now let us see the same thing for the convex mirror. Now this is a convex mirror and here we observe the direction of the incident light. So now from the pole in the direction of incident light, if I move in the direction of incident light, if I move in the direction of incident light, so I will be getting here a positive direction. So this direction will now be the positive direction. And if a measurement is made along opposite to the direction of incident light, so here pole is the origin. Do remember that pole is origin. Okay. So from the pole, this direction will be taken as negative direction, whereas the other direction on this side, we will be getting a positive direction. Okay. Now, similar to this, we will be making for convex mirror. So for convex mirror, what can you say about the radius of curvature?
Negative.
Okay, see. Yes,
Positive.
positive. See, this direction is positive and radius of curvature is measured from pole to center of curvature. So pole to center of curvature, this is the direction. It will be taken as positive. So radius of curvature for convex mirror will be positive. Okay. What about the focal length?
Positive.
Positive. Focal length will be positive. Okay. Then what about the object distance?
Positive.
Okay. Okay. Where we will keep the object? Here or here? On which side we will keep the object?
Sorry, sir. Negative.
Negative. So object distance will be negative. Okay. What about the image distance? Yes. Sudhanshu, what about the image distance?
Neg
Joha, Joha,
Yes,
please participate. You should answer. Okay, actually, I'm not, I cannot see everyone over here. So I want everyone to answer. Okay. Subhansh, Siddhisri, Aman,
yes, sir.
everyone. So everyone please answer. What should be the sign of image distance for the convex mirror?
Sir, positive.
Positive, yes. For convex mirror, image distance should be positive. Got it? It will always be positive since for this case, every time for convex mirror, the image was always formed between pole and focus on this direction. So this was a positive direction. So I hope everyone has understood about the sign conventions.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Now there are two more points about the sign conventions, but those are not difficult to understand. They are easier than this. I'm just making them note here. So your third point about the sign convention is that all measurements above the principal axis are positive. Okay. So all the measurements above the principal axis are positive, and all measurements below the principal axis are negative. Okay. So I hope these are easy to understand. Okay. So for both of them, for the concave mirror and convex mirror, what can you say about the height of object? Suppose this is your object. So what can you say about the height of object?
Sir, it's positive.
It's positive. So height of object, we also represent it with the symbol HO. So HO means height of object. Height of object will always be positive. Even if it is kept inverted, then also height of object will be positive. And HI is denoted as the height of image. So what can you say when a real image is formed? What will be the height of image, positive or negative? Say here, when the real image is formed, it is always inverted. So what should be the height of image, positive or negative?
Sir, is it
Negative.
negative?
Negative.
Negative. It should be negative. And when a virtual image is formed, then what should be height of image?
Positive.
Positive.
Positive. So this is positive. Here this is also positive. So I hope everyone has understood this.
Yes, sir.
Yes, sir.
Now we will do mirror formula and try to solve at least one question from there. Okay. So we have the mirror formula. Okay, so the mirror formula is related as it is 1 by F equals 1 by V plus 1 by U. Siddhisri? Siddhisri? Yeah, Siddhisri, can you unmute yourself? Okay, see here. So your Dhriti, what does the symbol U represent?
So what?
Yeah, what does the symbol U represent here?
So you represent the object distance.
Yeah, U represent object distance. And what does the symbol V represent?
So the image distance.
Image distance. Very good. And what does F represent?
The focal length.
Yeah, F represents the focal length. Then you have the formula of magnification. We find out the value of magnification by the formula height of image divided by height of object. Okay. So your magnification, in magnification, we actually compare that how high the image is from. Is the image high or low? Just 1 minute. As compared Get one करता हूँ. Hey, अरे यार, ये पगली सबसे नाम था. Okay, see. So the HI represents height of image. Represents height of image, and HO represents height of object. Okay, so just I'm asking, if you get the value of magnification as say +3, so what can you guess about the image? From this formula, you have the formula of magnification as height of image over height of object, right? So what do you think should we get here? If you are getting suppose magnification value as +3, so what can you say? First of all, tell me that which one is bigger? Is the image bigger or is the object bigger?
Image.
Image.
Yeah,
Image.
yeah. So we will say that image is bigger than the object, right? So image is larger than the object. Okay. Then if you have here plus sign, so what does this plus sign mean?
So virtual image.
Virtual image. That means the image is erect, image is virtual. So everyone should be able to guess these things from the value of magnification. Okay. So can you get this? If we have the value of magnification as plus 0.3. So what does this value signify? Dhriti?
Yes, sir.
Okay, you are getting the value of magnification as plus 0.3. So what should be the meaning of this? Plus 0.3.
So
What
that
information we conclude?
so that the image is virtual.
Image is virtual Okay. Image is virtual, that we get from this plus sign. If the sign is plus, so it means the image is virtual. Okay. What do we get by this plus 0.3? 0.3 means which one is greater, image or object?
Image.
See, 0.3 means 3 by 10. Okay. And if you compare it with height of image to height of object, so which one is greater? Observe the
Height of
proportionality.
object.
Height of object is greater. That means here, in this case, you have a smaller image formed. The image formed is smaller, but virtual. Okay. Can anyone tell? Okay. So if the image is virtual, erect, and smaller, so which mirror has been used?
Sir,
Yeah.
convex mirror.
Convex mirror. So this is how you have to extract information given from the question, given in the question. If your question says that magnification is plus 0.3, so it is not only saying you plus 0.3, it is giving you a lot of information. Okay. Now Aman will tell that what about this if the magnification is equal to -1?
Sir, it's a real image.
It's a real and inverted image. Very good. And what about the size?
Sir, I think both of them are equal.
Both are equal. Okay. So see, real and inverted. Okay. And same size. So which mirror do you think has been used?
Concave.
Concave mirror. And can anyone tell that where is the object kept?
At C.
At C. So this is how you should be able to extract the information. This is for everyone. If there is anyone who is not getting how we are concluding, so please inform. So see, we obtained all this information just from the value of magnification. M equals to -1. It gives me a lot of information. Okay. What about this? If you get, suppose, if you have a magnification equals to -3. Joha, can you answer? Yeah. First of all, which type of image is this? Yeah, real and inverted. And what about size? Yeah. No, it's not the same size. Aryan, can you tell the size?
Size,
Yeah.
sir, it is same size, no, sir.
No.
Sir,
See,
it
the
is
value of
enlarged.
image is enlarged. The value of magnification is 3, which is greater than 1. 3 is greater than 1. So that means image is enlarged. How we are getting this all? We are getting this from this formula, magnification equals to height of image over height of object. So from this we are getting all this information. If you are able to extract this information, you will not be stuck in, you will not get stuck in any of the questions. Okay. So the formula of magnification is M equals HI by HO, and it is also equal to minus of VO minus of V by U. Minus of V by U. Okay. Now let's see a small question, and if you are able to do this. So let's see. Find the nature, position, and size of image. Find the nature, position, and size of image when the object is when an object of height when an object of sorry, height 5 centimeter is placed in front of a concave mirror of focal length in front of a concave mirror of focal length 20 centimeter at a distance of 30 centimeter from the pole or from the mirror. Let's see. Okay. So I hope you will be able to do this question. I'm sending this question for your homework. Okay. Anyone having any doubt?
No, sir.
Okay, so the question will be available in the PDF sheet on the WISE app. If anyone is having any problem, whatever we did today did not get, you can again see the video lecture. Okay, this will be with the name light L3 or L4 should be available. Okay. So bye everyone. Good night you all.
Bye, sir.
Bye, sir.
Thank you, sir.
Thank you, sir.